the diode equation in forward bias region. This is the equation of diode in forward bias region, where I is current in forward region, Is is saturation or scale current, V is applied voltage, Vt is thermal voltage, and the constant n has a value between 1 and 2, which depends on physical parameters of device. We take this n1 for diodes and we take this n2 for transistors. In general, we shall assume n is equals to 1 unless otherwise specified. The value of this saturation current is a function of temperature. For every 5-degree rise in temperature, the value of this saturation current is doubled. Now, look at this thermal voltage. This thermal voltage is given by the equation kT upon Q, where this K is Boltzmann's constant and the value of this constant is 1.38 into 10 raised to the power minus 23. Here this T is absolute temperature, which is in kelvins. This Q is current and its value is 1.6 into 10 raised to the power minus 19 coulombs. Now at room temperature, that is 20 degrees centigrade, when we put this value of Boltzmann constant and this value of current in this equation, we get Vt is equals to 25 millivolts or 0.025 volts. So in approximate circuit analysis, we use this value of thermal voltage at room temperature. We can also express this diode equation in logarithmic form. We know that common log means base 10 log. It tells you what power you must raise 10 to obtain the number x, that is n is equal to 10 raised to the power x. Similarly, second is natural log, which means base e log. It tells you what power you must raise e to obtain the number x, that is n is equal to e raised to the power x. So, which log you are going to apply here? You are going to apply natural log here because you have this e in your equation. So, after applying natural log on both sides of this equation, you will get ln I is equal to ln is e raised to the power v divided by n vt minus 1, or we can also write this equation as is ln e raised to the power v divided by n vt minus is ln 1. Here this ln is cancelling this e, and we know that the natural log of 1 is 0, so this whole term becomes 0. Now we'll get ln I is equal to is v divided by n vt. Now by rearranging we get v is equal to n vt ln I divided by is. So this is another way of writing diode equation in terms of V. Look at this example. If you have n is equal to 1 and voltage of silicon made diode is 0.7 volts, and you have to find current. So how you are going to find this current? You will use diode equation. I is equal to Is E V divided by NVT minus 1. Now what is Is? Take this Is 10 raised to the power minus 15. It is also fixed in most cases. Now we know what is V, we know what is N, and we know what is Vt. Vt is 0.025 volt. So after putting all these values in this equation, you will get I is equal to 1.44 into 10 raised to the power minus 3 amperes, or I is equal to 1.44 milliamperes. So this is how you are going to find current using diode equation. Now we will understand derivation for increasing current when voltage is increased in forward bias region. Now, for suppose current I1 is corresponding to diode voltage V1, and it is given by the equation I1 is equal to Is e raised to the power V1 divided by NVT, and we call this equation equation 1. Similarly, current I2 is corresponding to diode voltage